Hello, pre-calc. This is lesson 1.8, and I'm going to start by working problem number 11 from the homework. And the first thing I do recommend that you do is sketch this particular parabola. And I know that if I put a 0 in for x, I get 3. If I put a 1 in for x, I get 1. If I put a negative 1 in for x, I get positive 1 again, sorry. And so I know that this is what that would look like. And so I want to restrict the domain. So if I just looked at 0 to infinity, you want to just look at half of it, right? Because right now it fails. See how it fails? It goes through twice, the horizontal line test. But if I just look at 0 to infinity, it passes the horizontal line test. So that's my first step. And then I'm going to write my function. Instead of f of x, I'm going to put y, and then I'm going to change my x, or my y to an x, and my x to a y, and solve for y. It's a 2, it looks like a z. Oh my gosh. Okay, so y equals the square root of 3 minus x divided by 2, or 3/2 minus 1/2 x. So if we put in our y equals x, and this one right here is going to be that 0.11. So you had the 0.0311. So on, and this was regular f. So on the inverse of f, 3, 0, and 1, 1. I didn't want that whole thing to go away, but okay. And so it's going to look like this. And that will be your f inverse. Probably should have done it in a different color. F inverse. This is also known as f inverse instead of y, right? So there's your inverse, and we need to know now the domain of each. So we said that the domain of f was 0 to infinity, and the range of f was, because here's your f, right? This right here is your f, the one in blue right here, going down, 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 down like that. So it's going to be 0, range is going to be 3, or I'm sorry, negative infinity to 3. And for your f inverse, your domain is going to be negative infinity to 3. And your range is going to be 0 to infinity. So you see how they swapped domain and ranges. Okay, that was number 11. Oops, sorry. Number 12. This one, let's just think about what it looks like. 3 units this way to the left and 2 down. And this is the vertex of your normal absolute value function looks like that. We just shifted this point right here, 3 units to the left and 2 units down. So this is the point -3, -2. And it's going to go up 1 over 1. There's going to be a point up 1 over 1. There's going to be a point up 1 over 1. There's going to be a point. And then there would also be one going this way, but that's not going to be, we're not going to do that because it would, if we included that, it would fail the horizontal line test. So we are going to say that we're going to restrict our domain to -3 to infinity. Okay, that's our restricted domain for F. And you can see that your range is -2 to infinity. Okay, and so that's your F, and you already have that. Now remember that when you have a absolute value function, it can be written as a piecewise function. And so you can talk about everything in the absolute value is positive, which would give you x plus 3 minus 2, which would give you x plus 1. And that's for everything for x greater than or equal to -3. Or everything underneath your absolute, or in between your absolute value could be negative. And then that would be -x minus 3 minus 2. So -x minus 5. So it could be -x minus 5 for x less than -3. And the second one is the one we threw out. Okay, that's the one we said, oh, okay, we're not going to use that one. We're only going to use that one. So what we're actually looking at here, and I simplified it to y equals x plus 1. So change your x to a y, your y to an x, and solve for y, and that is your inverse. So there is your inverse, and if you have your xy points for f, we said -3, -2, we said -2, -1, we said -1, 0, we said 0, 1. You can do F inverse and just swap them, -2, -3, -1, -2, 0, -1, 1, 0. And so I'll do this in purple. So -2, -3. I have to extend it. Oh, that's a thick purple. 1, 2, let's put it about right there. Oh my goodness. I might need to change that, but I'm going to put my y equals x in, because it should be a reflection across the line y equals x, right? And oh my goodness, my purple is a little dark. I'm going to make it a little bit less than that. And then my next one is -1, -2, and then 0, -1, and then 1, 0. And so this is your F inverse. This is your F. This is y equals x. You can see that your domain is -2 for your inverse is -2. See, that's where it starts, -2 to infinity. So for F inverse, our domain, -2 to infinity, and our range will be -3 to infinity. So you can see how the F domain and range swapped with the F inverse domain and range. Okay? And that's how I would solve number 12. All right, number 13. It says, use the graphs of y equals f of x and y equals g of x to evaluate the expressions. So I made a chart for f, and then I'm going to make a chart for F inverse, okay? So I looked and I saw negative 4, 4, and then I saw this point right here, negative 2, 3. And then 0, 2, and then 1, 0. Even though a couple of those they didn't have dots on them, you should look and see if it goes straight through. You should go ahead and write those down. 2, negative 2, and then 4, negative 3. And so I'm just going to swap all these. So 4, negative 4, 3, negative 2, 2, 0, 0, 1, negative 2, 2, and negative 3, 4. And so I'm going to erase those because I'm going to draw my inverse in blue. So positive 4, negative 4. And then positive 3, negative 2. 2, 0. 0, 1. Negative 2, 2. Negative 3, 4. So connecting them. Okay, that's your y equals x. And you can see that it's a reflection across the line y equals x. All right, so F inverse of 0. So I'm going to go right here. F inverse of 0 is 1. And then, oh, now we got to do g. Sorry, I forgot we were going to do g. Here's our x and here's our g. So we have the point negative 4, negative 3. I also see it going through negative 3, negative 1. And then again, negative 2, 1. 0, 3. 1, 4. And then 3, 7. And so I can now make my G inverse ones. I'm just swapping these, negative 3, negative 4, negative 1, negative 3, 1, negative 2, 3, 0, 4, 1, 7, 3, and negative 3, negative 4, negative 1, negative 3, 1, negative 2, 3, 0, 4, 1, and this one's 5, 6, 7. This one's off the page. 7, 3, about right there. And again, if this was y equals x, it's a reflection across the line y equals x. So my G inverse of 0, you're actually going to have to estimate it because I don't see an x equals 0 here on the list of G's. So when I look at G inverse of 0, it looks like about negative 2.5. This is going to be F of G of 1. So G of 1 is negative 2, right? Right there. Or no, I'm sorry. I messed up. Sorry, guys. I did G inverse of 1. We wanted G of 1 is 4. And then plain old F of 4. Well, that's weird because it didn't even give you one that had an inverse. Ends up being negative 3. Because we just went F of 4, negative 3. And then G of, now what is F of, oops, what is f of negative 2? So f of negative 2 is 3. And this is another one that doesn't do an inverse. What is g of 3? 7. But here, this one does an inverse. So f inverse of, well, what is g of negative 4? G of negative 4 is negative 3. F inverse of negative 3 is 4. And this one is f inverse of g inverse of negative 1. So I go over here, g inverse of negative 1 is negative 3. So f inverse of negative 3 is 4. So those last two were both 4s. I hope that made sense. 19. The circumference of a child's head is related to the height of the child h by the equation h of c equals 2.15c minus 10.53, where both c and h are in inches. Express the head circumference c as a function of the height. So for this one, they want c in terms of h. So we're going to have to say, well, h is 2.15c minus 10.53. So I'm going to solve for c. So I would add 10.53 to both sides. And then divide by 2.15 on both sides. And that gives you your c of h. What is the predicted circumference of a child's head who measures 32 inches tall? So we want to know the circumference if their height is 32 inches. So I just put 32 in for h, and if I put this in my calculator, go ahead and put that in your calculator and see what you get, and then turn this back on, and you should have gotten 19.78 inches. Find the inverse of the linear function. F of x equals mx plus b, m not equal to 0. So I'm going to change my f of x to a y, and then I'm going to change my y to an x, and my x to a y, and solve for y. Subtract b from both sides, divide by m on both sides. So my f inverse is x minus b over m. And again, m cannot be 0. So number 21. In June 2015, you are planning a trip to Japan and find the exchange rate for converting US dollars X to yen Y was Y equals 123.65X. And so X is dollars, Y is yen, and it says how many yen could you get for 100 US dollars? So you want yen, and dollars is X. So this is going to be 12,365 yen. What is the inverse function and what conversion does it represent? So the inverse function, you change your y to an x and you change your x to a y and solve. So x over 123.65 is my y. And that is going to convert yen to dollars. While in Tokyo, you have lunch in an outside cafe at a cost of 2,000 yen. How much was that in US dollars? So 2,000 yen over 123.65, because I'm using this equation. And if I put that in my calculator, how many dollars is it? You should get $16.17. The consumption of bottled water in the U.S. in gallons per person from 2005 to 2011 is shown in the table below. The time in years is given by T, where T equals 0 corresponds to 2005. What does the inverse represent? Okay, so the inverse is going to be the year for the given number of gallons of water consumed in the U.S. in gallons. I think I said gallons twice, though, sorry. The year for the given number, sorry, I think I forgot the year for the given number, so whatever given number, I forgot 4, oh my goodness, the year for the given number of gallons of water consumed in the U.S. in gallons, okay? Which I think that doesn't make sense, but basically here you put a year in and you're getting the gallons, where on the inverse you're putting the gallons in and you're getting the year. Okay, so it's like your y value is what your answer is. That's what you're getting from that function. So is f inverse a function? So let's think about that, because we've got, this is your x basically, right? And this is your f of x. Okay, they're using t and f of t. But if we do the inverse, we're swapping all those. So the x becomes 25.4, 27.6, 29.0, 28.5, 27.6, 28.3, 29.2. And the f inverse of x becomes 0, 1, 2, 3, 4, 5, and 6. So the bad thing is that when you think of it in terms of domain and range, when you're talking about f inverse here, and think about these are all your domains, and 25.4 goes to year 0, 27.6 goes to year 1, 29.0 goes to year 2, 28.5 goes to year 3, but then at year 4, look, it's 27.6 again. So this one goes to 1 and 4. So therefore, it is not a function, because you cannot have an x going to 2 different y's, or it's going to fail the the vertical line test. So this causes you failure of the vertical line test for the inverse function. So f inverse of x is not a function because, for example, $27.6 goes to 1 and 27.6 goes to 4. So it fails the vertical line test. Now, if the inverse fails the vertical line test, doesn't that mean that the original function, that means that that's equivalent to, I'll just put equals, same thing as, that your original function f of t must have failed the horizontal line test. If your inverse is failing the vertical line test, okay? So anyway, you really shouldn't even found the inverse. I mean, you know, but it's just not going to be a function. Okay, I think we're done.